The second half of section 13.2 deals with reference angles. And reference angles are going to be extremely important for our evaluations of our trig functions. Now, what is a reference angle? Some very important words I want you to underline. A reference angle is always a positive acute angle that is formed between the terminal side of theta and the x-axis. When you find a reference angle, people, it has to meet all four of those criteria. It's positive, it's acute. It between the terminal side and the x-axis. Now, reference angles are always used to evaluate the trig functions. Never use any other angle other than a reference angle. Now let's discuss reference angles and what they are. I want you to draw this circle, and I'm putting in the y-axis, and now I'm putting in the x-axis. And what we're going to draw here is we're going to draw a 110 degree, we're going to draw an 80 degree angle, which is going to be about right there. So again, the initial side is on the x-axis, my red line, and my terminal side goes to there, which is 80 degrees. The question is, what is the reference angle and where is it? Well, first of all, it's positive. Second of all, it's acute, which means it's less than 90, and it has to be between the terminal side and the x-axis. Well, my terminal side is my blue line that I'm putting black hash marks on, and my x-axis is the red line. This same angle is the reference angle. So the reference angle here is 80 degrees because it meets all four criteria. Now, how does that, you may say, why is that any different? Well, let's do this example. Draw another circle, and there's my y-axis, there's my x-axis. Okay, and now, my initial side is right there. We're going to draw a 130 degree angle. 130 degrees would be about right there. This big angle right there is 130 degrees. Now, the question is, where is my reference angle? Well, the angle has to be positive, it's got to be acute, and it's between the terminal side and the x-axis. Well, people, here is my terminal side, and the only acute angle using that and the x-axis is the one in between this x-axis right there. That angle that I'm darkening in black, that angle is the reference angle because it's positive, it's acute, and it's between the two sides. Well, how big is that? Well, all the way around to here is 180. This angle was 130. That makes my reference angle 50 degrees because 50 plus 130 is 180. That is my reference angle. I hope that makes sense. Now let's do one problem. It's got two parts to it. A, find the reference angle for theta, and B, find the exact value of the 6 trig functions for theta. Well, first of all, what is theta? Well, I'm going to tell you theta is 330 degrees. So what we need to do is we need to draw that. There's my initial side. And what I'm going to do is I'm going to draw theta, which is going to be this red line right there. There's theta, 330 degrees. Now, what I'm going to do is I am going to drop, it meets the circle here, I'm going to draw this little vertical line right here to make ourselves a right triangle. And I'm going to tell you that the blue line is 2 units long and the red line is 2 square roots of 3. Question number A. find the reference angle for theta. Well, theta has to be the angle between the initial side, which I'm highlighting in blue, and the terminal side, which is what is in red. And it's got to be positive and it's got to be acute. That would be this angle in here. That's the only acute angle between those two sides. Obviously, if it's 330 degrees around, the reference angle would be 30. Now, what type of triangle does that make that? Well, that makes this a 30, 60, 90 triangle. The shortest side is 2. The medium side is 2 square roots of 3. How long is the longest side? Well, we all know that all you got to do is take the shortest side, double it to get the longest side, so the longest side has to be 4. Now, we had to do that because we want the values of all 6 trig functions. Sine, cosine, and tangent, which we will do first, and then cosecant, secant, and cotangent, which we will do second. Well, we've gone through this a lot before. Here's my reference angle. That's the angle I got to use to figure out my trig values. So, sine of 30 degrees, which is also the same as sine of 330. This value, by the way, is negative 2 because this coordinate, or this point right here, would have a coordinate that would have a coordinate of 2 square roots of 3, and then negative 2 if we were in the coordinate plane. So we got to use the negative sign. I'll rewrite this a little neater. We need to use the negative 2 because that's the coordinate. So, sine of 30 degrees, opposite over hypotenuse. That would be negative 2/4, which reduces to negative 1/2. Cosine of 30, adjacent over hypotenuse. Well, this is the adjacent side, which would be 2 square roots of 3 over the hypotenuse, which is 4. Now, 2 over 4 reduces, so I'm going to get square root of 3. Square root of 3 over 2, because 2/4 reduces to 1/2. The tangent of 30. Tangent is opposite over adjacent. That's negative 2 over 2 square roots of 3. Now, we all know you can't leave square root of 3 in the denominator, so I'm going to times top and bottom by square root of 3. And that's going to give me an answer of negative 2 square roots of 3 divided by square root of 3 times square root of 3 is 3 times 2. That's over 6. But now negative 2 over 6 reduces. Now I'm going to erase this work here. Negative 2 over 6 reduces. And what I have is negative square root of 3 over 3. Good. Cosecant. That's sine flipped upside down. So all I do is take negative 1/2, flip it upside down. I get negative 2 over 1. That's the cosecant. Cosine. I flip that upside down. That's 2 over the square root of 3. Can't leave it like that. I got to times top and bottom by the square root of 3. So I get 2 square roots of 3 over 3. That's the secant. And cotangent, I got to flip this upside down. I'm sorry, this right here where my arrow is, sorry. Flip that upside down. I get 3 over negative square root of 3. Well, I got to times top and bottom by square root of 3 again. And so I will get negative 3 square roots of 3 over 3. And those two reduce, which just leaves me with negative square root of 3, which is the value of cotangent. And people, that is how you use reference angles to evaluate the 6 trig functions. Please remember reference angles.